So today's class, a function question. What is the question? F of x equal to 2x plus 1 upon x minus 3. We have to show that the function is invertible with respect to domain r minus 3, set of all real numbers except 3, and codomain set of all real numbers except 2. So a mapping with the domain r minus 3, codomain r minus 2 given by f of x equal to 2x plus 1 by x minus 3. Then we have to show that it is invertible and hence find its inverse. So invertible, it should be 1 to 1 and on to. So dear student, without the discussion of 1 to 1 as well as on to, we cannot come to the conclusion that the function is invertible, and then only we have to get its inverse. So let us start the discussion of 1 to 1 and then on to. For 1 to 1, and we have to start with the assumption two equal images. So let us assume let f of x1 one image and f of x2 another image. We are considering these two are equal for all x1 comma x2 are the pre-images of the given domain R minus the element 3. It is given that 2x plus 1 upon x minus 3 is an image of the pre-image x. Then the image of x1, 2x1 plus 1 upon x1 minus 3. The image of x2, 2x2 plus 1 upon x2 minus 3. After cross multiplication, 2x1 x2 and 1x2, then 2x1 into 3 minus 3 minus 6x1 and minus 3. The other side 2x1 x2, in the place of x2 it will come x1 cross multiplication 1 time x1. Here minus 6x1 means the other side minus 6x2, the constant going to be same. Now what to do? We have to simplify. Just cancel out same term on the both the side, minus 3 also cancel. Now rearrange the term. x1 can be taken same side, minus 7 times x1, the other side minus 7 times x2. Then simplify or divide the entire equation by minus 7. We can get x1 equal to x2. Dear student, we have started our discussion with the and same images and concluded with the corresponding pre-images are equal. So this shows that f is 1 to 1. Remember, another name of 1 to 1, injective or injection. So the function is injection. So the first part is ready, proved. Now we have to discuss second part, that is on to. For the second part, on to. So dear student, how to start on to? We have to take explicit function of y. That is y as a function of f of x. This is known as explicit function of y. Y in term of x. Then y equal to, what is f of x? From the question 2x plus 1 by x minus 3. From this, what is our purpose? The explicit function of y should be converted into explicit function of x. Y in term of x means we are going to write x in term of y. Just cross multiply xy minus 3y minus 2x is equal to 1. Leave constant alone other side. What is the purpose? We need the term containing x all left side. So take x term, x time y minus 2. The other side 1 plus 3y. Now x equal to 1 plus 3y by y minus 2. We have succeeded in conversion of in explicit function of y into explicit function of x. Okay, so dear student, x equal to 1 plus 3y by y minus 2. Look at the question. X all real number except 3. So belongs to R, real number. Remember, the entire rational expression real number mean belongs to real number. The value belongs to real number mean, remember, the denominator should not be 0. So x equal to 1 plus 3y by y minus 2 is a real number except 3 or overall real number mean, then y minus 2 is other than 0. Y is not equal to 2. That means y will take all real number except 2. Y is not equal to 2. Now look at the question. R minus 2 is codomain. Here we have got R minus 2 is range. Now conclude range and codomain equal. So whenever range and codomain equal, the function is always onto or surjection. So we have concluded the function is one-to-one as well as onto. So the function is one-to-one as well as onto mean we can say this is bijective as well as invertible. Just go through it. So because of the function is one-to-one and onto, so f is bijective and invertible. That means inverse exists. So this implies f is invertible with the inverse. F inverse of y. Yes, the given function f of x means its corresponding inverse f inverse of y equal to x. And that is, what is inverse? F inverse of y. F inverse of y, so the function should be in term of y. So what is the x conversion? Look at the x equal to 1 plus 3y by y minus 2. So the x is replaced by the 1 plus 3y by y minus 2, 1 plus 3y by y minus 2. So this is inverse of the function f of x equal to 2x plus 1 upon x minus 3 with the domain r minus the element 3 and codomain r minus element 2. Okay, understood? So dear student, next question, the domain r minus 3 and codomain also r minus 3. Both the domain and the codomain same, and f of x equal to 3x plus 1 by x minus 3, and we have to show that f composition f of x equal to x. From this detail we have to get it f inverse of x. So remember the concept, f composition g is identity function in y and g composition f is also identity function in x mean. What is the conclusion? The function is bijection. The function is one-to-one onto bijection, and f inverse is nothing but g or g inverse equal to f. This is for two different functions. Remember one more point. Instead of f composition g or g composition, both are same. In case f composition f of x equal to x, straight away we can say f is invertible with the inverse f equal to f inverse. So the given function itself knows self-image. So these 2 points are very important. So in this case, we are not going to discuss separately one-to-one and on-to. According to the question, let us start to find the value of f composition f of x. What is the meaning? F of x is the domain of f. So we have to write f of x is now pre-image of f. So in the place of x, we have to take f of x 3 times f of x plus 1 by f of x minus 3. Now f of x value we can take straight away 3x plus 1 upon x minus 3 and plus 1 divided by 3x plus 1 upon x minus 3 minus 3. Dear student, just to simplify, 3 times 3x 9x plus 3 plus x minus 3, here 3x plus 1 minus 3x and plus 9. So finally, and minus 3 and plus 3 cancel, all x term cancel, 9x plus x 10x, 10x by 10x. Listen, f composition f of x equal to x mean, according to this rule, f is invertible and f inverse of x equal to f of x. So what is f inverse of x? 3x plus 1 by x minus 3. Okay, very simple question. So don't forget this technique. Here we did not discuss one-to-one on-to separately as we discussed in the previous question. This is different type of questions. Understand. Thank you.